Okay, today's lesson is on properties of numbers. Our objectives for today are that the students will classify real numbers and that the students will use properties to simplify expressions. Our vocabulary for today. Rational numbers can be expressed as a ratio, which means fraction, and irrational numbers are decimal numbers that never terminate or end or repeat. An example is square roots that are not perfect squares. Integers, are the set of numbers where you have all your negative numbers, not including decimals and fractions, 0, and then all your positive numbers, not including decimals and fractions. Whole numbers are the set of numbers from 0, including all of your positive numbers, again, no decimals or fractions. And natural numbers are the set of numbers where you're just dealing with your positive whole numbers or your positive numbers, no fractions or decimals. So every number that we are going to be dealing with is a real number. Real numbers then get moved into two different ones. They get moved into rational and irrational. If it's irrational, it's just irrational. That's like the square root of 3, pi, square root of 15, all those are irrational. Rational has different classifications. You have integers, which are your negatives, zeros, and your positives. You then have your whole numbers, where you get rid of your negatives, and then you have your natural numbers after that, where you get rid of your 0. So that's the biggest part of the vocabulary at the beginning. So our first example is we want to classify numbers, so name the set of numbers to which each number belongs. With negative 23, since it's negative, it is not going to be a whole number or a natural number, so we start with it being an integer. It is a negative integer. After integer, it is also rational, and then they are all right now going to be real. Alright, the square root of 50. 50 is not a perfect square. It is not 4, 9, 16, 25, 36, or so on. So it is not a rational number. It is an irrational number, and it is also real. Negative 4 over 9. Since it is a fraction, it is not natural, it is not whole, and it is not an integer. So this is just rational and real. That's how you go ahead and classify numbers. So let's move on to properties. Our first property that we have is the commutative property, which is that A, in addition A plus B, is equal to B plus A. It says that within addition I can switch them and not have any issues. In multiplication, it is A times B equals B times A. Again, the order of A and B does not matter in multiplication. Associative, this is that A plus B, in parentheses then plus C, is equal to A plus where B plus C are inside the parentheses. So I can add them and group them any way that I want and it still works. Same goes here. A times B times C is equal to A times B times C. Again, I can group them however I want and it's still the same answer. Identity, the additive identity, is that A plus 0 equals A, which is also equal to 0 plus A. The identity means that my answer is the same as my non-zero number. Multiplication, now we're not using 0, we're using 1. So A times 1 is equal to A, which is also equal to 1 times A. Inverse. When you think of the additive inverse, we are talking about its opposite. So that means that when we're dealing with addition, we want it to be 0. So that's a plus negative a equals 0. For multiplication, we want to think reciprocal. So that means a times 1 over a equals 1. So we want to think the reciprocal. Closure is that a plus b is a real number. A times b is a real number. Distributive, that's a times b plus c is equal to ab plus ac. Taking and multiplying a to both b and c. So our next example, name properties of real numbers. We want to name the property illustrated by each. So 5 times 4, and then we have 4 times 13 is equal to 5 times 4 times 13. Well, that looks like it's going to be the associative property of multiplication. So associative prop of multiplication. Right here, where we have 2 times x plus 3 is equal to 2x plus 3, because 6 is 3 times 2, we know that this is the distributive property. Alright, moving on. So, the additive and multiplicative inverses. So find the additive inverse and multiplicative inverse for negative 5 over 3. So again, additive, I told you in that chart, you want to think opposite. So, we have negative 5/8. The opposite of that is positive 5/8. That is going to be your additive inverse. Your multiplicative is the reciprocal. Remember that reciprocal means you want to flip the fraction. So negative 5/8 becomes negative 8 over 5. The key here is that the sign stays. Okay, so simplifying an expression. Since we have the 3 and the 5 on the outside, we want to use the distributive property. So 3 times 2 is 6q, 3 times r is 3r, plus 5 times 4 is 20q, and then 5 times negative 7 is negative 35r. That's the first part. You could, at this point, use the commutative property to group your r's together and your q's together, but you don't have to. You could just now combine like terms. 6q plus 20q is 26q. 3r minus 35r is negative 32r. And there you have it. That is all for this lesson. Now please complete the problem set or the assignment associated with it. If you have any questions, please let me know as I'm coming around.